Hey everybody, I'm Chili. Welcome back to Intermediate C++ Tutorial 7. Today, we're going to take our first step into proper modern C++. We're going to learn about streams and about strings. Now in Tutorial 6, we learned about the rule of 3 and about resource management. And that was a kind of a bridge from the low-level C-type stuff into the high-level C++ stuff. With these skills, now we have the ability to make smart objects that handle our resources for us. So we could, for example, now make a smart string object and encapsulate all the operations that we want to do on the string, and it would be very convenient. But that would also be very stupid because there already exists a very good string class in the C++ standard library. And that is what we're going to be learning about today. We're going to learn about the stuff that is going to replace con.io and the chili string bullshit. And this is the actual stuff that we're going to be using whenever we want to do console input-output and whenever we want to manipulate strings. Now this tutorial is going to be a basic overview. It's going to be a tour showing off the highlights of these things. I'm not going to go into every dirty little detail, but it should be enough to get you started, and then you're going to be able to, do your own research and experimentation and practice with this shit on your own. Alright, let's get started here. We're going to create a new empty project. You're going to add your int main in here, source file. Another thing I've added in here is I've added the files dict.txt and warp.txt. So I'm not sure if we're going to be using them yet, but added them in just in case. Now we're not using con.io anymore. We say fuck off to the con.io. We're going to be including IOStream. And when you include IOStream, you get two global stream objects created. That's std cout and std cin for console output and console input. And they are stream objects just like ofstream and ifstream. So, as you would expect for cout, you can do put. You can put a character onto the console. Let's put an AF.
What's it going to be? Catania, quickly. Okay. Well, at least you get the money for the letters. 900.
An F.
Sorry.
But if you run this, it's going to exit immediately, so we need to have a way of stopping it from quitting the program. So we can do std, and we can call cin.get, and this will just get a character, and it'll wait until you input. So now if we do this, we get an AF, and it's going to wait. Now, here's the difference between cin.get and getch from con.io. cin.get will not return. You can hit as many characters as you want. It will not return until you hit enter. And when you hit enter, I think it returns the first character you typed. So it's a little different. You can't do single keystroke detection. And that's mainly the reason why I didn't go with IOStream for my my low-level tutorials there. You've also got other familiar functions that streams have, like for example, cout.seekp. You can seek the output pointer. It doesn't make any goddamn sense with a console to seek. That's usually what you do with files, but I mean, the function is there anyways. I've never used it on cout, but it's there. And yeah, so you can do the stuff that I showed you with ofstream and ifstream. And you might be saying, well, that's great, but I don't see a print function. What if I want to print out a string? Well, you print out strings to a stream like this. You would go cout, and then you do this double great less than thing. We call this the insertion operator. And then you just put the string, so, fuckers. And if I do this, it works. We got the uckers from here. Fuckers. So yeah, you want to print out a string to cout, you just got to put these arrows in here. It's a very visual way of doing things. And that's not all. Check this shit out. We can go std cout. Let's put a number in there. Let's put fuckers 69. So what do you expect to happen here? Well, if you put a number out, like if you put 69, you would get a character. I believe it was, I forget what it was. Maybe capital E. But if you do insertion operator 69, what it does is it converts that shit to a string and outputs the string for you. So you get the actual text representation of the decimal number 69. And that my friends, is also pretty fucking sweet. And I know what you're saying now. You're being chilly. What is this dark magic? Burn him at the stake. But the way this works is this operator is originally a binary shift operator. So it shifts bits to the left in a binary number. But for the O stream, for a stream object, it has been overloaded so that it has a different meaning. And the meaning in this one is insertion. Take the thing on the right and jam it into the stream. And depending on what the thing is, it will have different behavior. So for a string, it just jams the characters of that string into the stream. For an int, it converts the int to a string and then jams it out into the stream. And that's not all. You can actually chain these together. So you can write out a whole string of these and it will output them in this order into the stream, converting as necessary. Fucker 69, blaze it faggot 420. It's all good. Now, the reason why you can do this chaining here is because the insertion operator, it returns a reference to see out when it's completed. So what happens is this gets evaluated, the string x gets inserted into the stream, and then this operation returns a reference to see out. And then after that, this gets evaluated here. And it converts 5 to a string and outputs it to see out. And then this operation again returns a reference to see out. And then you evaluate this. That's how operation chaining works. And that is why, let me see if I can bring it up here. That is why when we created vec2, I insisted that your plus and equals operators and your multiply and equals, they return a reference to the vector, because these kinds of operations, they should also support chaining. Assignment operations should support chaining, and also the insertion operator for streams supports chaining. What it doesn't support is shooting your friend in the face with a shotgun, but that's a different story. So you can output strings, you can output ints, you can also output floats, and it will convert those floats nicely to a string. There are special things that you can also put into the stream, specially defined, I don't know what you call them, manipulators. So one of them is called std endl, and what that will do is that will give you an end line. So if I copy this and paste that, we will get 2 lines of shit. Yeah. End line, end line. And that's just the same as inserting a string with a \n, except there is one difference, and that is endl. It will put an end line, but it also flushes the stream. So what that means is that if there is some buffered data that hasn't been written, like if you're writing to a file on the disk, it will buffer that data in the memory and try to write it as efficiently as possible. But if you flush the stream, you're constantly flushing the buffer before it can build up. And so that will reduce your performance. So normally I don't worry about it, but if you are doing some performance critical access, especially of files, don't use endl. Otherwise, use whatever the fuck you want. I don't give a shit. Now, if we include another header, and I'm going to include it right now, called IO manip, we get a whole bunch of manipulators that we can use. Let me just show you one of them, and it's called the set W. So we'll go std set W, and that will set a fixed width for output. So let's set a fixed width of 7. So now if I output something and it's less than 7, it will add padding to make it so it's 7 wide. So let's add in some numbers here. So I've just chained together a bunch of integers going out here with set W manipulators and end line at the end. I'm going to duplicate this line like this, and then I'm just going to mess around with the numbers a little bit. Like so, and then if I get rid of this dumb F here and I print it out, you will see that our numbers are now nicely formatted regardless of their width. The lines aren't all scattered, they're nicely lined up here. And we can do the same sort of stuff with the cin. With cin, it's not called insertion operator, it's called extraction operator, and it will extract characters from the cin stream, and it will convert them as necessary. So if we, try to extract from cin into ndix, it's going to extract characters and convert to an int, and then it'll do this loop. So let's try it out. How many dix do I want? I want, lots of dicks. And then we get a lot of dicks, and it closes immediately. And that's a kind of weird thing, because we put this cin get here to pause the program, but it didn't pause, it closed immediately. And the reason for that is it can be explained if you understand how the stream works. So when we do cin and dicks, what happens is it looks at the stream and it extracts characters until it reaches a delimiter, an end case. And the end case is, for example, a space, a white space, or a new line when you hit the return key. So it will extract these characters, but it's going to leave the return key on the stream. And so then when we call cin get, it will get that return key right away, and we will have no chance to do input. So we can see here that cin get is actually kind of shitty for this job, but we can do a quick workaround to make it work here. We can just do cin.get after we do the extraction operator to get that enter key that we pressed. And if we do that, should work fine. Yeah, there we go. And then we can press enter and we quit. So now using get like this to clear the buffer works, but it's got some problems. Like, what happens if the user types some shit after they type 420 but before they press enter? It just blows right back past that get. So get is only going to get the first thing that remains on the buffer. Now what our friend the extraction operator does is it pulls out characters from the stream until it hits a kind of delimiter. So it's going to pull out numeric characters, and when it hits a space, it's going to say, oh, this ain't a number anymore. I'm going to stop right here. So it's going to leave all this stuff on the buffer, and that's not good. So that means that if you want to clear the buffer, you've got to call get a whole bunch of times. How many times? Who the fuck knows? It's not going to work. It's a bad system. Now, input streams have a nice function called ignore that allows us to ignore stuff from the input stream. It takes two parameters. One is the maximum number of characters to ignore, and the other parameter is the delimiter character, and that means the character at which it will stop ignoring. So what ignore does is it consumes characters from the stream and discards them until it consumes the delimiter, and it will discard that, but then it will stop, or until it has discarded this amount of characters. So if we put a big number in here and we put the delimiter as enter, now no matter what we input here, it's going to extract the number and then it's going to ignore the rest of the characters. So you see here it's stopping until I press enter. So that's great. This is a little annoying though, because I mean, as programmers, we don't like to just put in magic numbers. Like, this is just a big number. What if the user types in more characters than this number? Then we've got a problem. So what we would like to do is we would like to put the maximum possible number in here, because we want to ignore as many characters as possible until we hit the new line. There's a little trick that we can do for that. I wasn't planning on teaching this, but let's go balls deep in here. So we're going to go include limits, and what we got here is we got a fucking sweet class, and it's called std numeric limits, and it's templated. So let's put the type. Now the type of the character count, we can see it right here. It's std stream size. So we want to get the maximum stream size. So let's go numeric limits of std stream size, and then we call a static function max, I believe, and that will get us the maximum possible value for stream size. And as you can see, this works fine, no problems. And this numeric limits, this actually works for pretty much any goddamn type you want, any of the basic types that are built into C++. So you can see here we're outputting the minimums and maximums of a bunch of different types. If we try that out, it's going to look something like this. And there you go. So the minimum that car has is -128. The maximum that unsigned car has is 255. And the maximum that float has is, 3.4 times 10 to the 38. Good to know, I guess. So yeah, this stuff it comes in handy. A lot of times you want to know the extents of different types, and this tells you it in a very programmatic way, not just having you look it up and then type in some magic numbers into your program. Very sexy. Now you might think this is the input problem solved, but you would be wrong. Let's see what happens if we type in some bullshit into here. it just exits immediately. Why is that? Well, you try to extract an int from cin, but you've only got characters that can't possibly be an int. What happens? Well, the stream enters a fail state. It's an error, and it will now be in an error state. And you can't call cin get on a stream that is in an error state. It doesn't work. So all of the calls like cin ignore and cin get, they just fail and return immediately. So what you want to do is, after you've done a formatted input, maybe you want to check for an error, and lastly, what you want to do is you want to go cin.clear, and that will clear the error flags. And now if you type in an error, it will clear the error flags, and the second get will pause and wait for input, so it won't exit immediately. And this is the actual solution to the problem. You call clear, you call ignore, and then you can call get. And this is how we pause for user input and don't let the program exit immediately. And then now you can see why maybe I chose con.io instead of streams for my little introduction there. It's just a lot of little dumb details that I didn't want to go into in that situation there. Now here's the best part. This insertion operator and extraction operator stuff, it works for all streams. And you know, our file streams are just normal streams. So we can do this shit with files. So if we include fstream, we create an output file here, pubes.txt, and we jam some stuff into our output stream, including some numbers. What we get is, if we open up the file, we got pubes.txt in our working directory, and there you go. Daddy, would you like some sausages, with a nicely converted floating point number in the middle? Pretty goddamn sweet.
Daddy, would you like some sausage? Daddy, would you like some sausages? Daddy, would you like some sausage?
So yeah, that's the basics of streams, and as you can see, it's pretty convenient and pretty easy to use. A lot easier than, you know, writing all of your conversion functions and bullshit by yourself, I think. But I wanted to show you guys that stuff so you have an appreciation of what goes on under the hood when you insert like an integer or a number into a stream here, all that conversion and the algorithm that goes on behind that. Now let's move on to the second topic of this video, which is strings, std string. As you know from watching my videos, working with C strings manually is a pain in the ass, and it can cause a lot of problems. It's very easy to fuck up and introduce bugs into your code. Now, string is going to make our life a hell of a lot easier in that regard. So what we're going to do is, I'll just get rid of this code here. We're going to include string. So we can create a std string, we'll call it S, and you can initialize it like this. You can give it a value, and then you can jam that into cout if you like, and we'll just do std cin.get again. And that'll work as you would expect. Jams the string out there. You don't have to worry about, you know, creating a buffer, figuring out what size the buffer should be, and making sure you don't go over that size. No, you just tell it, make me a string of this size, and it just does it. You could also do it like this. S is equal to, you know, some string. This is mostly the most common way of doing it, I think, using an assignment. This also is initializing. And again, you just get your string out like that. Std string has an overload for the plus and the plus and equal operators, and you can concatenate strings, so you can jam them together like this. So here, m is equal to s plus t, and if you run that, you get that boy. Pretty good. You can also take an existing string and, you know, put extra characters onto the back. So I can do push back, and I can put a character on here. I can put an exclamation mark at the end, and that will add characters to the end of the string. And the beauty of this is you don't have to resize the buffer or anything. You don't have to worry about buffer sizes. It automatically happens behind the scenes. So the memory size is dynamically resized for you. Now, what if you want to know, you know, the size of a string? Well, you just go, cout, there we go. You just go m.size. And that will tell you the size of the string in characters. Here you go, 7 characters, 1, 2, 3, 4, 5, 6, 7. And this this doesn't include, this is only the actual payload character. So there's no real concept of a null terminator in std string. It might have a null terminator under the in the implementation under the hood, but you never have to deal with the bullshit of the null terminator when you're dealing with the interface of string. You just think of it as the characters that are the actual payload, and that's it. There are also functions to convert values into strings. So if you want to build up a string with numbers in it, you can do, for example, m plus and equals, and then we go std to string, and then you pass in the number that you want to put in there, and it will convert that. And toString has a bunch of overloads, so it can detect what value you're passing it, and it will call the corresponding function. It's all overloaded, you see. And if you run that, you get the 420, and then the 10 at the end. Why is there a 10 at the end there? Ah, that's the size. All right, makes sense. Now, if you want to go in the other direction, you want to convert a string into an integer, there are functions for that too. String to integer, s2i converts a string to an integer, and if we run this, we should see num is equal to some garbage, and we step over, it is equal to 69. And there are versions of this function for all the things that you want to convert into. So let's take a look at the reference page for string. And just like with ifstream and ofstream, string is just a specialization of basic string. So it's a basic string of cars. So yeah, basic string. It's got a bunch of functions. We've already seen some of them here. The assignment operator. You can access a specific character, just like you would access a character in an array with indexing. And the index operator works much as you would expect. It allows you to treat the string object as an array of cars and access them individually. You can read from the string. You can read from a specific car position, and you can write to a specific car position. And if you run this program, yeah, you know what you get. You know what you get. Again, I've shown you push back. You can do pop back, which removes the last character. You can clear out the entire string. What else can we do here? Again, this is concatenating two strings. You can compare strings to see which one would come first in the dictionary. You can swap strings. This stuff isn't super important. Here it is, numeric conversions. So here's all the stuff to convert strings to integer types, strings to floating point, double type. And here's one with a whole bunch of overloads where you can convert any kind of type to a string. And yeah, that is pretty much it. Where's the other one that I told you guys about? And there it is, size. So you can call size and get the size of the string. I think length is another name for size. You can also call empty, and that will tell you whether the string is empty or not. Let's take a quick look at some of these utility functions. First of all, erase. Removes characters. Seems pretty simple. It's got a few overloads here. You're going to look at this, you're going to say, Chili, what is this iterator bullshit? Well, I'm going to explain iterators, but they really deserve their own video. So for right now, just pretend like any of these functions that have iterator in them, pretend like they don't even exist. So the only one we're interested in is this one, erase. We pass it an index to where we want to start erasing characters, and we pass it a count, how many characters we want to erase. And it will remove those characters from the string. Seems pretty simple. Look at this code. How can we improve it? Well, let's call string.erase 16.1. That will erase starting from the 16th index character, and we'll erase exactly one character. We run that, and we get try our black anus, which is, I believe a market improvement. There's also insert, which allows us to, insert characters. You look at this, say, holy shit, look at all these fucking overloads. But again, remember, iterator is dead to us. I have no iterator. So yeah, well, all we got is these ones. And really, all we're going to look at is number 2 and number 4. They both take an index where you want to insert and a string what you want to insert. And it either takes, standard C string or a reference to a basic string. And if we wanted to do that, we could go something like this. So let's call string.insert at index 18 with the string here cream pies using the standard, C string, and you get your black anus cream pies. Sounds delicious. So we can insert characters, we can remove characters, we can also replace a range of characters with some different characters with replace here. And again, you got a whole shit ton of them. But I mean, if you ignore the ones that say iterator, then the amount goes down a little bit. The basic idea is you got a position where you want to replace characters, and you've got a count of how many characters you want to replace, and then you've got a string that is going to replace those characters. And that can be, you know, basic string reference, or I believe it can also be a C string car pointer. Just so I don't get labeled as a huge racist, let's replace 5 characters starting at index 8 with the string white. And if we do that, we get try our white anus cream pies. There you go. You got quality and diversity and mazel tov. Another thing you can do is get a substring of a current string if you just want part of it. And you do that, this function will return a new basic string object. And you give it a position and you give it a count, and it will give you the substring. So for example, we could do const string sub is equal to string.substring 14.4. So that will do 4 characters starting at the index 14. And we put that out onto the world, and we get a big old anus. Great. And let's look at one more. Let's look at resize here. So resize has 2 versions, count and car. And what it'll do is it'll resize the string for you. So if we do, let's see here. If we do str.resize, and let's resize it to 3 characters long and print that out. So that'll look something like this. Try. And we can also resize it to be larger, and when we do that, we can specify what it should fill the extra space with. So let's resize to 69, and we're going to fill the extra space with question marks. And then we can output that again, and that'll look something like this. Try, and there you go. Bunch of functions. Let's look at one more function. So we've got a bunch of search functions in here. Let's look at the basic one, find. Find characters in the string. And this will allow you to search for the position of a string inside of the string that you have. So you can specify the string you want to search for, and you can specify the place where you want to start your search. And it will return the index of where that is. So we can go the anus is at, and then we go string.find anus. And the second parameter, the starting point, I believe it can start off, defaults to 0, so that's fine. So find the anus, and then we go std and l. And I believe the anus, where's the anus at? The anus is at 14, which I believe is correct if you count. Now here's an interesting thing. Let's change the code here a little bit. So here, if I change the code a little bit, the string find will store its result in this integer here, iAnus, the new product from Apple. And if iAnus is not equal to std string npos, then we do the normal printing, the anus is at. But if iAnus is equal to npos, we say there is no anus. So why does this work? What are we doing here? Well, the find function, it will return npos if no such substring is found. And npos is just a constant that is defined in std string. So you can check for npos to see whether or not the substring exists at all in the string. So here we're checking to see if it exists, and it does exist. The anus is at 14. But if we copy this code out here and we paste it, we cut it out and we paste it before we did our modification, then we get the message there is no anus. Now we can use string as a kind of dynamic storage to store very large amounts of data if we wanted. So let's try and read in one of those big files now using string. So we can read the entire novel into the string by, creating a string, opening the file, and then what we do is we do a simple while loop here, and this is a car, so it's going to extract single characters out of the stream. It's not going to convert to an integer type. It's just going to extract it as a single character, and then it's going to push back into the book. Now, the reason why this works is because when this operation, this is going to return a reference to the stream, to in. So when this operation fails, in is going to evaluate the false because it's going to be in a fail state, and then the loop will exit. So this works fine. This will read until the end of file, but it won't insert any garbage into here. I should have probably put end reading at the end of here. We'll do that. We'll make that end reading. And there we go. Begin reading, end reading. Now you see there's a bit of a pause there. It takes a little while. But we can do it. We can read the entire text into a string. And the string is going to be dynamically resized as we insert stuff into it. So we don't have to, tell it the size at the beginning. It will resize itself as necessary. Now, if we put this into release mode, we can see right away it reads it much faster. And there are ways of making it read even faster, but we don't need to worry about them right now. It's not a big deal. Now, you might be wondering, well, we're extracting single characters out of the file, and then we're pushing them into the string. What if we extract out of the file into the string? What does that do? Well, here's a simple loop here. I'm going to extract from the file into the book, and then I'm going to insert that into cout. I'm going to do that 20 times, and let's see what happens. So here you go. You've got all these words with no spaces. So basically what the extraction operator does if you use a string is it will ignore the white space, and it will use the white space as separators, and it will just take out the words. So when you extract into a string, it will extract one word, ignoring the white space, which is useful in some situations, but might be annoying in others. What if you want to extract single lines at a time? Well, if you want to extract a whole line, you can go std get line. And this one takes, it's kind of hard to read, but here it takes a stream, iStream. So we can pass it our in. And then here it takes a basic string, so we can pass it our string book. And this will extract an entire line, I believe including the carriage return. It extracts that, but it doesn't put the carriage return into the string. And then here we're going to take that extracted line and jam it into cout. And if we do that 20 times, we get 20 lines of the book minus the carriage returns. So if we jam in some std and l in here, now we're going to get 20 lines of the book. And getLine is a very common way of getting text input from a file and putting it into a string. Perhaps the most common way of doing that. All right, let me talk about one last cool thing, and then we'll wrap it up for this video. So there's a function that you can use to output debug messages to the debugger window. So to use this function, it's for Visual Studio, and it requires we include Windows. So windows.h, there we go. Now the function name is, let's get rid of this bullshit here. The function name is output debug string, and it takes a C string. It doesn't take a std string. So let's just put some bullshit with 3 L's apparently, and \n. And then let's start the debugger. We'll put it here, and we'll put this in debug mode. We'll run it. So here we are, and let me just find the window because I don't believe I have it. There's an output window for debug, but you have to have it. Output, there we go. So here's the output for the debugger. Now if we step over this line of code, bullshit appears in the debugger output. So you can send messages to this debugger output window from your program. And you might be saying, well, okay, cool story, bro, but I could just send messages to this window. But of course, imagine now you're doing something in the Chili framework. We haven't gone over outputting text in the Chili framework yet. So it would be nice to be able to output to the debugger window. And there's other reasons why you would want to output there as well. So, okay, that's cool, but this debugger window only takes C strings. It doesn't take std string. So what are we going to do? Well, we can do this. If we have a std string, and I'll just call it D out, and we're going to set it equal to pubes. And now I want to pass this to a function that takes a C string. If I try to pass it just like this, the compiler is obviously going to complain because those things aren't compatible. But what you can do is you can call dout.c underscore string, and that's a function, C string, and this will give you a pointer to a C string that contains the same characters as the string. The implementation of what it does is it could be different. It could be a completely different buffer than what is used for the underlying string, or it could just be a pointer to the already existing string characters. But that's not important. The only thing that is important is that we can use this to pass our std strings to functions that require C strings. And we do this. We run it. And there you go, pubes on the output, just like mom wanted. Now, let's conjure up a little scenario here. So let's say we've got some values in our program A, B, and C, and we want to output those values to the debug window for diagnostics. So what we would do is, we'd have to create a std string. We'll call this one dout, and we're going to set it equal to, we'll just put a little message, some shit, and then we'll do some shit, and then we'll do A, and then we'll do plus, and then std to string A, and then we'll do the same for all the other ones. So if we build a string with our message, some shit, and then A, B, C, and the values, and at the end we put a new line, note that you can't do std end L here because that's for streams, and this is a string, so it doesn't make any sense. So we build our string up, and then we go dout.cstring, and that should output our data to the debugger window. Let's try it out. And why did I get some warnings there? I could have sworn. Let's try to rebuild. No, build, clean, build, rebuild. Yeah, warning. Initializing conversion from double to int. This is an int, right? That's stupid. This is supposed to be a float. And that was being an F. There we go. All right, let's try this again. Run that, and now when we step over this, we got our message, some shit, A, B, C. Wait. Oh, well, there's B and then there's B again. Okay, I'm a retard. So here we see our built up string, and then when we step over, we get our message out here. Very nice. And now that's fine. That's fine. It works. But it's kind of annoying to type std to string every time. It's a pain in the ass. If we were just outputting to C out, it would be so much easier. It would look so much nicer. If only there were a way to do that with a string. Well, there is, and the name of it is string stream. So if we include S stream, we can create a string stream object, and that's just std string stream, and we'll just call it SS. And this will allow us to input things into this string stream, and it will build up a text buffer of everything we've input. So we can input this string into SS, and then we can insert A into SS, and we do that for all the other shit. And now look at how much nicer this is. We got it all in one line here, inserting everything into the string stream. Now all we got to do is figure a way to get that into our debug thing. So we go ss dot str. That gets us the string. And then we do dot c string to get us the C string. So from the string stream, we get a string. From the string, we get a C string. And then we can output that to debug. And lo and behold, there you go. You got everything you want. All right, now for the homework, what we're going to do is we are going to revisit the old SNEC game, specifically the poison SNEC that we created, whenever we did that. And what we're going to do for the homework is we are going to create a configuration file that allows us to set some options for the SNEC game. It's like a poor man's option menu. And you often see this kind of thing for games that are in alpha, or for games where you just don't give a fuck. And basically what it is, it's going to be a text file. It's going to have some, headings, and it's going to have some numbers for configuration values. And the user can open up the text file, set the values, and that will change how the game works. So this is going to have two parts. You're going to have to be able to make things dynamic now, because you're not going to know the board size, for example, at compile time. And you're going to need to be able to read and parse this text file to get the information out of it. And I want to add one more little wrinkle to it, and that is that you can't just read the numbers in order. You have to be able to read it even if the headings are out of order. So you have to identify the headings and read the values into the proper places. So you have to be able to read the sections, the headings, whatever you want to call it, independent of order. And yeah, that's the homework. For your reference, here are the 5 parameters that I'll be doing in the homework solution video. I'll also put this information up on the wiki page, and feel free to add any extra features you want. And that's it for tutorial 7. I hope you've got a general idea now about strings and about streams. It's okay if you still feel a little shaky, a little unsure, because this was just an overview, just a quick tour. And we will be going over these topics in the future more and more as we use these libraries. But more importantly, you guys need to experiment and practice on this stuff of your own. You need to spend some time reading the references yourself, not only because it's important to learn how to do string stuff, that's important, but also because it's fucking important to get used to looking shit up in reference documents, reference pages, like, for example, cppreference.com. And I want to introduce to you one more, and that is c++.com. It's same idea. You've got references for the whole standard library in here, but it might be a little easier to understand c++.com. The explanations are a little simpler than on CPP reference. CPP reference is probably the #1 reference for professionals because it's very specific. It's highly precise and technically correct, but sometimes the explanations, they're not the easiest to understand. So also do take a look at c++.com. I'll link both of these in the wiki page, but it is super important that you guys look this shit up on your own and experiment with all these things, because you're going to be using them all the goddamn time. Thanks for watching. I hope you liked the video. If you did, please click the like button. It helps me a lot. And I will see you soon with some more C++.